Okay, let's continue with that. Okay, I'm going to talk about the heights of the height. Okay, typically of the nut height, things like that. So when we're going to design out the height of the nut height, things like that. Okay, for instance, like this one, we have a bolt like that. Okay, you gotta have the bolt to true whatever, and then the nut head is gonna be the M things show you out there. Okay, so the M is gonna show you the heights of the nut head as shown in figure 8.10 here. Dimension of the screw and bolts and the nuts fast, things like that for case by case. The case B. Okay, typically, what I said it here. Okay, typically the machine properties of the nut and bolt should be identical or in the same property class. It means, okay, if we pick up the bolts and nuts because put in pairs, things like that, okay? However, the failures of the bolts and nuts fasten may be classified into three categories as follows. Number one, failures of the bolts and bolt traits, okay? And number two, failure of nut traits, okay? And number three, failures of bolt due to shear stress. Of course, the three cases, things like that, we don't allow anything to be happen anyway. And then decide of both in the trade pattern should be done to avoid the failures of both trades. Okay, this is one important thing. Typically, the strength of the thread should be greater than the strength of the bolts due to the shear stress. Therefore, the failure most likely happened to the bolt due to the shear stress before the failure to the thread. Practically, the heights of the nut threads, the height of the nut, M is dependent upon the ratio of D over P. Okay, so therefore M should be greater than this. When the nut is made of non-ferrous material, M is going to be greater than two times two times of the diameters. The standard trace and the bolts and nut are made the same of material is M equal to 0.8 times D. Figure 8.10 shows the screw fastener and the bolts and nut fastener and the corresponding dimension. Okay, so therefore, typically the M is going to show you up there. It's going to look like that. Okay, so therefore, another one, another one that what we gonna show you just gonna be the L sub E. Okay, in case of we gonna make a L sub E, okay, in the workpiece, things like that, okay? We're gonna have a recommendation based on this. It's gonna show you just in the table, okay? Uh, in the recommendation of the thread lengths in the workpiece, as you show you just in the figure 8.10 a while ago, okay, the L sub E, okay, for the material of the workpiece, with steel, things like that, for the property class, okay, typically that's what I said to you already in Thailand, 3.6, okay, up to 4.6, things like that, all the way, and 4.8 above, things like that, this is about high class, things like that, okay, this is going to be the things that what we recommended for the cast iron, things like that. For the copper alloy, whatever, we should have the L sub E in the workpiece look like that, okay? And then for the other material, look like that, okay? And then, okay, number six, I'm gonna put the case by case anyway. Number six is the design of the trade fan is subject to a specific loading. I just write up this kind of textbook to show you just case by case anyway. Okay, this is the case number six, okay? I show you the case of, okay, I would like to just hanging the loading or loading the to lift up some weight, okay, from move up the load from place by place anyway. For instance, see, I'm gonna move a machine, okay, from place to place, things like that, okay. For instance, see, like in the example, a machine of weight 2 ton, okay, I would like to move it from one place to another place, things like that, okay. So therefore, I'm gonna use this kind of thing as an example anyway, okay. For example, okay, let's go for it. A machine with 2 ton is fixed with a trade hooks as shown below. Okay, given that a trade hooks is made of trade with property class of 6.8, okay, show you up there, and the safety factor of 5, okay, to mean the diameters of trade hooks, okay. The machine weight of 2 ton, right? 2 times 1,000 times 9.81 is going to be the total weights of it. Safety factor of 5, so therefore the allowable load times by 5 is going to be like that. So therefore, the property cost of 6.8, right? So therefore, as shown in table 8.3, okay, I use the cost pitch, right? I required 98,000 something. So I find in the table there, I find the force, the proof force is 84,000 up to 108,000, things like that. So therefore, I find the diameter of these 20. And then it's gonna be 1,008,000, things like that. Okay, so that's why I selected on that. So therefore I just make the sigma u from table 8.5. You have a look at it, table 8.5. I just make selection of this one, right? 0.8. I show you up there. So therefore I just make a L sub e, okay, of 1. Oh, sorry, L sub e, right? I'm sorry. L sub E is going to be 1. I'm sorry, this one, right? Okay. L sub E is going to be this one, right? I'm sorry, this one, right? This one, right? So I should have L sub E is going to be this. So the diameter is going to be this. This is going to be the answer. Okay. And then this one is going to be another type. Okay. It's going to be the things that what I put a case on it. It's gonna be the things that what I could show you just for the case of the trade fastener subject to the tensile force, like a hammer mill, things like that, by the friction force. If I tied it much more, okay, I'm gonna have some more friction force, so therefore I can generate more torque on this arm, things like that. Okay, the same thing happened. So this kind of thing, this initial torque of the trade required for the torque, so that's why the torque gonna be more if I got the Fi gonna be more on the trade here. Okay, so therefore the torque is gonna be more, and required torque for the Titan, and then C is gonna be coefficient of friction. It's gonna 0.5 is gonna be the thread is lubricated. This is gonna be not lubricated. This is gonna be dry. It means not lubricated at all. Okay. This one is B is gonna be nominal diameter, and S sub I is gonna be for the initial condition anyway, for the force of the initial condition. Uh, Example 8.2 is gonna be on the example of this one. Okay, 7. Okay, at 7 then. Okay, so you may have a look at by yourself. Okay, and then for number 9, okay, this is very important. Okay, for the engineering, mechanical engineering, and a trade finance subject to initial tensile force and external loading. Okay, I'm going to talk in more details about this. Okay, let me stop for a while. Okay.